All right, let's talk about turning those awesome ideas in your head into something real you can actually hold. Bridging that gap between what if and check this out. We're going to dive into how you can build your own gadgets and gizmos from scratch. So let's just jump right in.
So, you've totally been there, right? That light bulb moment? Maybe an idea for an automatic plant water for your hostel room, or a smart desk lamp that changes color. But then, reality hits. How in the world do you actually build something like that? It feels like you'd need a whole lab and a ton of experience. Well, what if I told you that the starting point is way, way simpler than you think?
Okay, so here it is. This is your new superpower. It's called the Arduino Uno. This little blue board, it's basically the key to unlocking a whole universe of custom electronics. And trust me, it's not just some random piece of hardware. It's an entire platform that's built to make building things fast, fun, and honestly, super powerful, whether you're an artist or a final year engineering student.
So what is this thing, really? Well, think of it like a tiny little computer that you can program. It's the brain of your entire project. It's got this amazing ability to read what's happening in the real world, through sensors. We call that input. And then it can do something about it, like turn on a light, spin a motor, whatever. That's the output. It's literally the bridge that connects your lines of code to a real physical thing. All right, let's take a quick look at what we're working with here. See that big chip in the middle? That's the AT 328. That's the brain, doing all the heavy lifting. The USB port, pretty obvious, right? That's how you connect it to your computer to upload your code and give it power. Then you've got these rows of pins. The digital pins are for simple on-off stuff. Think of them as light switches. The analog pins, on the other hand, can read a whole range of values, which is perfect for sensors. And that round power jack, that's so your project can live on its own, away from your laptop. And believe it or not, that's pretty much all you need to get going.
Okay, so if the Arduino is your superpower, then you need to learn its language to control it, right? In the Arduino world, we don't just write programs, we write sketches. I kind of like that. It's like you're sketching out an idea. But think of it more like learning spells. Each line of code is a command that brings your creation to life. And don't worry, these spells are way easier to learn than anything in your engineering textbooks.
Now, every single Arduino sketch, no matter how complicated, is built on two main parts. Just two. You've got void setup and void loop. The idea is super simple. The code you put inside setup, it runs only one time, right when you plug the board in. This is for all your prep work, telling the board what's what. But the loop function, that's the main event. Whatever you put in there will run again and again and again, forever, basically, until you pull the plug. It's the heart of your project. So the very first spell you're probably going to use inside that setup function is called pin mode. This one is absolutely crucial. You have to tell each pin what its job is going to be. Is it an input, meaning is it supposed to listen for something like a button being pressed, or is it an output, ready to send out a signal to, say, turn on a light? You've got to decide and declare this for every single pin you plan on using. No exceptions.
Okay, so you've told a pin it's an output. Now what? Well, now you need a spell to actually do something with it. And that spell is digital write function. This is your main action command. It's super straightforward. You just tell it which pin you're talking to and what value to send. If you write high, you're sending 5 volts. That's on. If you write low, you're sending 0 volts. That's off. On, off. It's literally that simple. All right, enough theory. Theory's great, but let's actually make something happen, right? It's time for what we call the hello world of electronics. We're going to blink an LED. And seriously, this is a huge moment. It's that first time you see your code jump out of the screen and do something in the real world. It's your first big win. The setup for this is super easy. Just grab an LED. You'll notice it has 2 legs, one's longer than the other. The long leg is the positive one, and you're going to connect that to digital pin 12 on your Arduino. The short leg, the negative one, just goes to any of the pins labeled G and D, which stands for ground. Oh, and we're going to stick a small resistor in there too. That's just to make sure we don't accidentally fry the LED with too much power. Easy peasy.
Okay, let's break down the code. First, in setup, we've got pin mode 12 output. All that's doing is telling the Arduino, hey, pin 12 is for sending stuff out. And remember, that only runs once. Then we jump into the loop. The first thing we do is digital write 12 high. Boom, that sends power to pin 12 and the LED turns on. Then delay 1000. That just tells the Arduino to chill for 1000 milliseconds, which is 1 second. Next, digital write 12 low. That cuts the power and the LED turns off. And of course, another 1 second delay. And since this is all in the loop, it just repeats forever. On, wait, off, wait, on, off. And just like that, you've controlled a physical light with nothing but code. How cool is that?
Awesome. So you've controlled an output, you've made something happen. But what about the other way around? Let's give our project some senses. Let's make it aware of the world around it by adding an input. And for that, we're going to use a cool little device called an ultrasonic sensor. So this little guy, the HCSR04, is basically like giving your project eyes and ears. It works almost exactly like sonar on a submarine or how a bat navigates in the dark. It's really clever. It just sends out a tiny high-frequency sound pulse, a ping, and then it waits and listens for the echo. And by measuring exactly how long that echo takes to come back, it can figure out how far away something is. Simple, but super effective. So how do we actually use it? Well, it's all about two specific pins on the sensor. Trig, which stands for trigger, and echo. Here's the sequence. First, our Arduino sends a quick little pulse to the trig pin. That's our way of telling the sensor, okay, send out your sound ping now. As soon as it does that, the echo pin on the sensor goes high. It stays high until the echo comes bouncing back, and then it immediately goes low. So our job with the Arduino is just to measure how long that echo pin was high. That time tells us everything. And of course, the code is what makes this all work. In setup function, it's just like before. We set our trig pin as an output because we're sending a signal to it, and we set the echo pin as an input because we're listening from it. Makes sense, right? Then in the loop function, we send that quick pulse to the trigger. And then here's the magic new function, pulse in. This function does exactly what we need. It just waits and measures the time, in microseconds, that the echo pin stays high. We take that number, plug it into a simple formula to convert it to centimeters, and bam, your project can now see and measure distance. Okay, this is awesome. We've controlled light, and we've sensed distance, we have output and input. Now let's learn the final core skill, motion. It's time to make our project actually move and interact with the physical world. And to do that, we're going to use something called a servo motor. Now, a servo motor is a little different from the regular motors you might be thinking of, the ones that just spin and spin. A servo's whole deal is precision. You can tell it, go to 45 degrees, and it will zip right to that exact spot and hold its position. Tell it to go to 180, and it'll do the same. This ability to control the exact angle is a total game changer. It's why they're used in everything from robotics to camera stabilizers, anything that needs precise controlled movement. And the best part? Wiring one of these up is super simple. They almost always have 3 wires. Red is for power, so that goes straight to the 5V pin on the Arduino. The black or brown one is ground, so that goes to a GND pin. And the last wire, which is usually yellow or orange, is the signal wire. That's the important one. It's how we send our commands. You just connect that to one of the digital pins. That's it. The code for this is also surprisingly easy, and that's all thanks to a pre-built library that comes with the Arduino software. All you have to do is include the servo library right at the top of your sketch. Then you create a servo object. Think of it as giving your servo a name, like my servo. In setup, you just tell that object which pin it's attached to. And then in the loop, it's as simple as myservo.rightAngle. So here, we tell it to go to 0 degrees, wait a second, then go to 90 degrees, wait a second, then 180, and the loop starts over. That's literally all there is to it. You now have precise robotic control. And just like that, you've got it. You now have the fundamental building blocks for pretty much any invention you can think of. I mean, think about it. You've gone from making a tiny light blink to sensing the world around you to creating actual physical motion. Your journey as a maker, your quest, it's really just getting started. Let's just recap what we've actually done here. You got to know the Arduino Uno board. You learned the essential spells of the code, setup, loop, pin mode, and digital write. You made light, you gave your project senses, and you gave it motion. Controlling output, reading input, and creating movement, seriously, these 3 skills are the foundation for almost any electronics project you could ever dream up. So, I guess that leaves just one last question. You've learned how to code, how to sense, and how to move. You have the superpowers. The real question is, what are you going to build first? A smart device for your room? A small robot? Something just for fun? The possibilities are, and I mean this, absolutely endless. Now, go make something cool.